Let's look at the second page of vgraphs. Okay, so here's our motion. We can see that we can break this into two bits. We have a CVPM bit first and then a CAPM bit. I can tell that because of the slope of the velocity graphs. Okay, so we're first moving with a constant velocity. So how are we doing that? Is moving, we'll call it backwards if you like, at a constant speed. Then what does it do? Then it goes from here to here. So it's going from this speed to 0, which means it's slowing down. And when we go from negative velocity to positive velocity, we're changing direction. And we're going from 0 velocity to a big positive velocity. So we're speeding up. So we start off going backwards at constant speed, and then we slow down, change direction, and go the other way faster and faster. Okay, so two separate parts. The way we want to separate it is CVPM versus CAPM. So the CVPM part, this is my initial position. Moving with that V, I'm calling positive to the right. That would be the end. And this interval, I have a delta x of whatever it is, and that takes a delta t of 2 seconds. Okay, then this is the beginning of my next interval. So this is my VI, negative 4 meters per second. I'm still going to the left for a little while, but then I slow, stop, and come back around, and my final displacement is positive, because if I look at this area versus this area, that's much more positive area. So my total displacement during the CAPM section will be definitely positive. I'll end up further to the right than where I started. And pretty fast, so a long velocity vector. Okay, during this interval, I have a delta x of whatever it is. I have a delta t of 6 seconds. And my acceleration, I'm running out of room here a little bit. My acceleration is this way. It has to be a positive, because the slope here is positive, and we call it positive to the right. So the acceleration is to the right. The initial velocity to the left, and the final velocity to the right. Okay, determining the displacement from 0 to 4, I need to find the area from 0 to 4 seconds. And this does encompass two different models, but they both tell me the same thing about finding displacement from the velocity graph, that I need to find the area. So the area of this one is, we have 8 meters in the first little triangle, and then 4 meters in the next triangle. So the way I get this is it's negative 4 meters per second for 2 seconds. That's the box there, the square, plus this is a triangle, so 1/2 times 2 seconds times this is negative 4 meters per second. That gives us negative 4 meters. So altogether we're at negative 12 meters during that interval. The displacement from 4 to 8 is this triangle. So that's 1/2 times, it's 4 seconds wide, and it is 8 meters per second tall, which is going to give me 16 meters. Okay, finding the displacement from 2 to 6. I'm definitely finding the area here, but let's use symmetry to our advantage here. 4 is right at the midpoint there, and the slope never changes there. So those areas are going to cancel out. They're symmetrical. So we can do that sort of by inspection of the symmetry of the triangles. Okay, determine the object's acceleration at that point. Really, the acceleration along this whole interval is the same. So I can find it anywhere, any convenient interval here, and that would be also the acceleration at 4. So the slope of that of that CAPM section is, I'll go from the end to the beginning, 8 meters per second minus negative 4 meters per second, and that happened from, it ended at 8 seconds and began at 2 seconds. So that's going to be 12 meters per second over 6 seconds, which is 2 meters per second squared. Okay, possible position graph for the object. The reason it's only a possible position graph is that we don't know the starting position here. So any graph that has the same shape as the one I draw is a possible position graph. We don't know where to put that graph. It could shift up or down. Okay, the first section here is CVPM, which means it's linear, and it's linear with a negative slope. So if I start here, then I go down with a negative slope for 2 seconds, wherever that's going to be. And then the slope is going to get less negative and then eventually go to 0. So I take this negative slope and I get less negative and go to 0. So this second section here is curved, with that curve starting out steep and ending up more shallow and flat ultimately at 4 seconds. And then the slope is going to get steeper and steeper, but in the positive direction. So I have a line in the first section connected to this curve here.